Good morning, student. Myself Vinay. Today we are going to study about the BBT for coordination compound. Coordination compound in which the metal atoms are surrounded by the ligands. Ligands are the donor atoms. So we have two types of ligands: strong ligand and weak ligands. Strong ligand brings more splitting, that is high splitting, which leads to the pairing of the electrons of metal and forms the low spin complex, while weak ligand lesser splitting, so no pairing of electron, forms the high spin complex. These are the sum of the strong ligands. Just you have to remember only strong ligands, remaining else are the weak ligands. Strong ligands are carbonyl, cyano, triphenyl phosphate, nitro, bipyridine, ethylene diamine, ammonia, isothiocyanate, pyridine and EDTA. So guys, you have to just only remember these strong ligands. Except these others are the weak ligands. Let's start with the example. So I have taken the example of tetracyanonickelate. So we are going to determine the hybridization of the nickel over here complex. So there are the tricks how to determine the hybridization. So the first rule is that you have to find the oxidation number of central metal atom. You have to find the oxidation number of central metal atom. Now here the central metal atom is nickel. So we have to go and find the oxidation state. So keep it X. Cyanide is -1, 4 equals to -2. So the X will be +2. That means the oxidation state of the nickel is +2. As you know, nickel atomic number 28, that is 3d8 4s2 configuration. Since it's +2, you have to remove the 2 electron from the outer shell. So for the nickel 2 plus, it is 3d8 4s0 4p0. Draw the orbital. This is 3d 4s and 4p. There are 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Then second rule, see the ligand. See the ligands. Now here Cn is a ligand and Cn is strong field ligand, and for the strong field ligand it brings the pairing of electron. So there will be pairing of electrons. So this electron will get paired over here. So you get a new orbital. This is 3d 4s 4p, and every electron will be paired now. Okay. Last and the final rule, third. See the coordination number. See the coordination number. So the coordination number over is 4. Just you have to count the 4 empty orbital. 1, 2, 3, 4. So it is D S P2 hybridized. So tetracyanonickelate is sp2 hybridized with the square planar geometry. Now look here, the electrons of the metal are paired, so it shows diamagnetic behavior. And one more thing, notice कि the D of the inner shell is participating. The D of the inner shell, that means it is 1 n minus 1D shell is participating orbital. So it is inner complex. It is inner complex. When n minus 1D orbital participate, it is the inner complex. When ND participate, it will form an outer complex. Hope so guys, you got it. Okay, first you have to find the oxygen state of a metal. Okay, then you have to write the configuration for the ionic metal. See the ligand, if strong, pairing, if it is weak, let it be. Third step, see the coordination number, and according to the coordination number, just count the number of the empty orbital. That will be your hybridization. Let's take one more example for you. Now, here I have taken the example of a hexaamine cobalt. Same rule, you have to find the oxygen state of the cobalt. So NH3 neutral ligand 0 equal to plus 3. So X is plus 3. So cobalt over is plus 3. Cobalt atomic number 27. The configuration will be 3d74s2. So plus 3, remove the 3 electrons. So for cobalt 3 plus, it will be 3d6 4s0 4p0. Okay, draw the orbital according to the rule. 4s and this will be your 4p. So this is 3d 4s 4p. 6 electrons, 1 2 3 4 5, and this is the 6th electron. What was the second rule? See the ligand. Now here the ligand is strong ligand. Ligand is a strong. Strong means you have to bring the pairing. So pairing of electron will take place. The new orbital formed will be so this is 3d 4s 4p. What is the third rule? See the coordination number. Here coordination number is 6. So just count the 6 empty orbital. 1 2 3 4 5 6. It is from here till here. That is D2 sp3. So it is D2 sp3 hybridized. And the geometry, possible geometry is octahedral. Since every electrons are paired, it is diamagnetic property. And the inner d orbital shell is participating, so it is again an inner complex. It is a inner complex. Let's take one of the example with the weak field ligand. Same cobalt. So here oxygen state of the cobalt again is plus 3. So I'm directly writing the orbital of cobalt 3 plus, that is 3d6 4s0 4p0 4d0. So let's draw 3d 4s. This is your 4p and 4d. 3d 4s 4p 4d. 3d 6 electrons, 1 2 3 4 5, and the 6th one pair. Okay, now what was the second step? See the ligand. Now fluorine is the weak field ligand, so no pairing of electrons, so the electron will remain as it is. What is the third rule? Count the number of empty orbitals. चलो count करते हैं. 1 2 3 4 5 6. Coordination number 6. So 6 you counted. It is S, P3 and D2. It is sp3 D2. Again geometry is same. It is octahedral. But since there is an unpaired electrons, it shows paramagnetic behavior. And the last thing is that the D of the outermost shell is participating, so it is an outer complex. It is an outer complex. See the difference. When the strong field ligand is approaching, diamagnetic, that means low spin, and here high spin complex is been formed when the weak field ligand is approaches. One of the most important example, tetraamine copper. Now listen carefully. So find the first step, oxidation state of a metal. So here the oxidation of copper is 2 plus over here because Na3 is the neutral ligand, so copper is 2 plus. Now copper is 29, so it is 3d10 4s1. So for 2 plus it will be 3d9 4s0 4p0. Let's draw the orbital. Four S 4p. So this is 3d 4s 4p. D9. So 1 2 3 4 5 6 7 8 and 9. Now this was the first step. Now see the second step. See the ligand. So your ligand is the strong ligand. Ligand is a strong ligand. So it is strong ligand. So pairing of electrons is there is no another electron to pair this. It will remain as it is. Now there is a rule. If possible, means if there is a possibility to form inner complex, then electron get jump from lower energy level to higher energy level. Jump from lower energy level to higher energy level. This take place if the ligand is strong. This take place only in presence of strong ligand, or over here NH3 is a strong ligand, so the this unpaired electron will jump from here and enter into the third shell orbital of P. So you get the new configuration. For P, so this is 3D 4s 4p, and the electron will jump over here. Okay, now what is the final rule? See the coordination number. Coordination number is 4. So coordination number 4, so you have to count just and 4 empty orbitals. So 1 2 3 4. It is dsp2 hybridized. That means it is a square planar geometry. There is an unpaired electrons, so it is paramagnetic. And finally it is an inner complex because the D of the inner shell is participating, so it is an inner complex. Guys, listen the rule. When there is one unpaired electrons and if there is a strong ligand, so there is a possibility if there is a possibility of formation of the inner complex, then make the electron to jump from lower energy level to the higher energy level. Hope so you got the VBT for the coordination compound. Thanks for watching the video.